All right, welcome to section 6.3, multivariate systems. That's a very complicated way to say three equations or three variables. So that's what we're going to deal with here in section 6.3. So we're definitely going to up the complexity level. When we have three equations and three variables, we generally need to use elimination to get down to two equations, two variables. We're going to show you how to do those a couple of different ways. We're going to use something called back substitution, and then we will use elimination to get to that point. So we'll go ahead and get started. First thing you're going to be asked to do in this section is to identify which order triples work or don't work for a system. So typically if we have two equations, two variables with x and y, we have an ordered pair. Now because we have three equations and three variables, we have ordered triples. So really what we're going to do is substitution. So we'll start with this first pair here. We're going to plug that in. If it works for the first equation, then we'll check the second one. If it works for the second one, then we check the third one. At any point down the line, if it doesn't work, then we stop and move on. So when I take this first point and plug it into this first equation, we get a true statement, 2 equal to 2. So then I'm going to go to the second equation, and when I plug 3, 3, negative 4 into the second equation, it does not work. We get a no, so at that point we can stop. It doesn't even make sense to plug it into the third one. So again, you plug the order triple in as long as it keeps working. As soon as you get one it doesn't work, then we punt. All right, negative 2, negative 3, 3. We're going to plug this again into the top equation, and it does work. So we move on to the middle equation, and we do get 19 equal to 19. So now we have to check the third equation, and it works for the third one as well. So that point is a solution of this system of equations. Based on the box for the third one, I think you can see it's not going to work here, but we'll click on that anyways. And we can see that when we plug this point into the first equation, we get 116 equal to 2, so that's not even close. So again, first part of your homework that you will see for this section is plugging numbers into the system, make sure it works. So very similar to what we did with two equations, two variables. All right, solving using back substitution. Now you can see I already have the answer here, which is fine. But again, we've got three equations, three variables, and they actually gave us z. So in this system, they actually told us what z is, which is nice. So now we're going to work backwards. We'll plug 6 in here, which will allow us to solve for y. And now that we have z and y, we'll plug that into the top equation, and that will allow us to solve for x. And so you can see here that y was negative 4, and x, when we solve here, is positive 5. All started with that given value of z, plug it in, and then we work backwards to find y, plug z and y in so that we can solve for x. Again, as we're watching this, if you need to go back to anything, just hit pause quick, or if you need to pause on something for processing time, please feel free to do that. All right, here's another system. This time, instead of z equal to a number, they told us that z is equal to 2y. And that's okay. That's going to work for us just fine. So what we're going to do here, we will plug this 2y in here for z. That will give me an equation all in terms of y. And so now, when I do that, I got negative 3y plus 4y. That worked out really well. So y is negative 3. You don't have to solve in order. We don't have to do z first. You don't have to do y first. You can kind of go out of order here. So in this case, we found y. And now that we know y, we can plug that back in here. And that will allow us to solve for z. So 2 times negative 3, we got z is negative 6. Now that I got 2 of the 3, I can plug those into this top one here. And that will allow me to solve for x. So you can see here I plugged in my values for y. Y was -3, z was -6, plugged them in, and I'm able to solve and find out that 2x equals 14, so then we divide, x is 7. Again, just like two equations, two variables, when you get done with that, you want to make sure that you write your order triple. So always finish by writing your order triple. Again, we knew z was 2y, plug it in. That allowed us to solve for y. Once I have y, I can plug back in for z, and then plug them both into the top equation to get x. Okay, this is about as difficult as we're going to get in this section. We can make it harder than this, but considering we're doing online and distance learning, this is as hard as we're going to get here. If you notice in this particular system, there's no equation that says z equals 7 or z equals 2y or something that's pretty straightforward where we can just plug it in and solve. So in this case, we have to do elimination twice. If you look at the top and bottom equation, you'll see that the x's will cancel. So we're going to start there. If I add that top and bottom equation, and you'll see that's why I put the blue asterisk here. If I add these two equations together, I get -6z equal to -18. That allows me to solve for z. Similarly, if you look at the middle and bottom equations, the y terms cancel out. And so if I add those two together, I find out that x is -2 since the y's cancel out. And so I get the y's to cancel out. I know what z is, so that allows me to plug 3 in for z, and I can get x. Now that I have x and z, I can plug it into any one of these equations that I want. I just plugged it into the bottom one, but you could have plugged it into any one you wanted to. And when we do that, you can see that y is -3. So again, now that I have x, y, and z, make sure you write them into order triple. I had it at the top of the slide, but whether you write at the top or the bottom doesn't matter. Always make sure if you have three equations, three variables, that you do indeed write that as an order triple. So this is as hard as it'll get. We'll cook these problems up so you'll see clearly that x's or y's will cancel out. We'll do this so you don't have to multiply either. It should be a visual thing where we can just see that it'll cancel out. All right, word problems. Two different scenarios for this. Two things we'll ask you to do. One, like this first problem, will just ask you to define variables and set up the equations. The next slide you'll see will actually do the whole thing where we define variables, set up the equations, and then solve. So in this case, we've got ice cream problem. We've got a couple different families going to Pops, and we're buying ice cream cones, sundaes, and milkshakes. So we'll start with our variables. That's the three things that we're buying. So there's our x, y, and z. You're not obligated to use x, y, and z. If you wanted to use c for cones and s for sundaes and m for milkshakes, you can. But typically we just use x, y, z to keep it simple. The first family, the Smith family, they bought 3 cones, 2 sundaes, 1 milkshake. There was their total cost. The Aiken family had 4 cones, 1 sundae, 2 milkshakes. There's their total. And then we had the Faber family, had 1 cone, 2 sundaes, 1 milkshake. Typically when you write these, you're going to want to try to line them up by variable. So in case there's one missing, for example, let's just say the Aiken family here didn't buy any sundaes. You want to leave a little gap there just so all your x's, y's, and z's line up. It just makes it easier for when you do have to solve. So again, make sure you read the directions on your homework, or when we get to this eventually on a quiz or test, whether it asks you to solve or in this case says do not solve. So here we just had to define variables, write the system. All right, the last one here that we have on our notes today. Now we're going to do the whole thing. We've got to define the variables, we got to write the system, and we got to solve. So here we got movies. We've got, if you read through the problem, we got adult tickets, popcorn, and drinks. So that's going to be our variables here. And then we've got Luke has 2 adult tickets, 1 popcorn, 2 drinks for $40.25. Anthony has 3 adult tickets and 2 drinks. So notice I skipped a spot here because he didn't buy any popcorn. So $45.50 was his total. And I cheaped out. I just bought tickets and no drinks and no popcorn. And so we got 4 adult tickets for $46 there. Again, by lining this up, it allows me to see what I have and don't have. And hopefully you see here, this is where we want to start. This equation's already singular in the fact that it only has 1 variable. And so we're going to start there by solving for x. So I'm simply going to divide 46 by 4. And by doing that, I already know that the price for an adult ticket is $11.50. Now that I know x, I'm going to plug it into this middle equation and solve for z. So I plug my $11.50 in for x, and once I subtract here, I can move this down. Ultimately, we'll end up dividing, and we figure out that the price for a beverage or soda is $5.50. Now that I have x and z, I can plug that back into the top here and figure out how much this popcorn is going to set you back. And so when we do that, you can see here 2 times our adult ticket price, 2 times the beverage price. That leaves y by itself. If I add these 2 together, I got 34. Move it over. Y is 6 1/4. And so the last thing I can do once I have y, again, write them as an order triple. I put the $sign here just because it's in context then of the problem. So we know an adult ticket's $11.50, popcorn 6 1/4, and a soda's $5.50. So with these word problems, again, we'll try to set them up where that you're given one of the variables in a situation like this where all you have to do is divide and get that first one, and then that'll allow you to plug it in. I can see on a previous problem whether or not you can solve by elimination, all that. So this just kind of makes it easier to start from here and work backwards. But again, clearly define your variables, set up that system, and make sure you write your final answer as an order triple. All right, we'll see you later this week in video chat. Thanks.